Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. Civil engineering is a discipline that deals with the design, construction, maintenance of roads, bridges, canals, dams, and buildings. It's the second oldest engineering discipline after military engineering. Civil engineers are hired by both the public sector and by private companies and individuals. If you take the time to look, the work of civil engineers is all around us. Without their work, the modern world would not exist. Our guest today is Ryan Fries, Associate Professor of Civil Engineering in the School of Engineering at Southern Illinois University. Dr. Fries studies and teaches transportation engineering, which includes traffic operations, road infrastructure, intelligent transportation systems, and transportation security. He's authored or co-authored over 50 journals, papers, conference proceedings, and research reports, as well as a textbook on transportation security. His current research includes investigating real-time traveler information requirements for the Illinois Department of Transportation. Dr. Ryan Fries, welcome to the conversation.
Thank you for having me.
So, first things first, I want to go back to that list, but not right this second, of things that I just talked about that you're involved in. But I want to just say that I first saw you appeared on Channel 2, St. Louis, and you were talking about road infrastructure because at that time Missouri had in front of it a funding bill that they were expecting the public to vote yes or no on. Unfortunately, the public overwhelmingly voted no. So here's the point. They voted no, and so the roads no longer have sufficient monies to keep the maintenance going on them. From an engineering point of view, how fast do roads begin to degrade when they are not being maintained on their regular schedule?
Well, it depends on the type of roadway, and it depends a lot on the type of traffic. So as engineers, when we design a roadway, we look at a design life, try to make a stretch of roadway last 15, 20 years or so, and then we estimate how many vehicles might drive over that of what different sizes, and based on that, we'll estimate how thick the pavement cross-section needs to be, what would be more appropriate, whether it's concrete or asphalt. And there's a whole method that engineers go through to make those decisions and make informed decisions so that we save the public money and provide a good long-term solution.
But after this road is built,
yes,
then there is a schedule that has to be maintained, that every X number of years the road has to be resurfaced so that when little fissures appear in the roadway, that moisture doesn't get down, and there you get the freeze-thaw cycle, which pushes the concrete apart. So they have to go and cut the surface and then resurface, oftentimes with asphalt over concrete, right?
It depends on the situation, but yes, part of the maintenance includes certainly filling cracks, making sure that water does not permeate below the pavement surface, because yes, if you've got water right below your pavement, when it freezes, it expands, and you have blowouts, you can pop your, basically take a small crack and make many larger cracks, and then you've got potholes that come from there as well. So it's, I would parallel it to those that are driving to not changing your oil in your car ever. Sure, it'll save you some money in the short term, but we all know in the long term it's going to cost a lot more. And that's the same way with maintaining our roads and pavement. And the design life or the expected life of a section of roadway certainly can go down, maybe by half. Depends on the section of roadway and the traffic on it.
Mm-hmm. So the people who think that they're saving money by not spending it today are actually, in fact, storing up the costs for later, which are going to be much greater. I was told both by MoDOT and IDOT district engineers that if a road misses its normal maintenance by as little as 2 years, the cost will go up 50%. If it misses it by 3 years, the cost could be 100% more than it would have been had it been done at the time. And if it goes beyond that, now it's much, much greater, because now you have, if they have to go all the way down to roadbed, in other words, they cut all the way down to the dirt below, that's costs a fortune.
I agree. That's called a full rebuild. That's where you need to basically take out everything from that road section and almost start over. So that's unfortunate. That does happen quite a bit, but it's part of the game now, and it's not just something that happens in the St. Louis area. This is a nationwide problem with all infrastructure, not just transportation as well. But for transportation, certainly, maintenance helps maintain and get the full life out of our pavements, so that we don't need to do a full rebuild but every 20 years. And a full rebuild isn't just adding cost compared to if you let it last its full design life. It causes everyone congestion. You've got to sit in more construction every summer or every construction season, instead of if we had the full design life out of our pavements. It doesn't take as long to close down a freeway lane to put sealant on cracks or to fix certain potholes. It takes much longer when it's a full rebuild. So we're not only making us cost more in capital in our taxes, but costing us more in congestion. So that's something no one likes.
No, and so having seen you and was interested in what you had to say, then I thought, no, why don't you come here and talk about that, which we're now doing. But you have other areas of expertise outside of just the basic, well, before we get there, again, let me ask this question. Concrete, we've been using concrete for decades, okay? Is there anything new on the horizon that is more flexible than concrete, which will last as long or longer?
Well, there is still continuous research on how we can ever improve the materials we use as engineers, whether it's asphalt or concrete. Both of those have a very strong industry and lobby support behind them, and different states go different routes. What I do know that is right now, concrete still is probably one of the best materials to use compared to asphalt and concrete. Concrete's better where you've got water problems. Asphalt doesn't last as long when you've got high water table underneath or drainage problems.
Well, my point is that, and again, a lot of people listening to this may not understand, you could drive your automobile or your light truck up and down the interstate for 100 years and barely put any wear or tear on the interstate. It's those trucks that are, 70,000 pounds, 100,000 pounds. If you were actually standing out there next to the road as these trucks go by, you can actually feel the concrete is actually moving, it's flexing, and that's what causes the breakup of the concrete over time, which is why you have to do all this maintenance we were talking about earlier. I'm wondering if there are any design engineers who are looking for a product like concrete that will be more flexible, that when that 100,000 pound weight goes over it, yeah, it flexes, but it's not going to flex in the way where the molecular damage is being done.
Now, there's two types of pavement, and we call asphalt pavement. Engineers call asphalt pavement flexible pavement because it does flex a bit when vehicles go over it. And on the contrary, concrete, we consider that rigid pavement. So they react differently, and they've both got pluses and minuses. The rigid pavement, yes, it's not going to flex when a larger vehicle goes over top, or it's not going to flex that much. Therefore, you're not going to have problems with rutting. For example, if you've ever driven over a section of roadway where you could see the divots for the tire tracks, that's called rutting.
Where it's doing
yes,
yes, yeah.
And
you better be right down the middle.
Exactly. That almost only happens with flexible pavement. However, with rigid pavement, it may not deform like that, but when it gets to its maximum stress level, or it's been loaded and unloaded enough times that it's fatigued, it will crack. So there's pluses and minuses to both. But I know some of the current research work has been going into making these materials more sustainable. For example,
we need a hybrid, obviously. I mean,
yes.
A hybrid of concrete and asphalt, but some new product. I would have thought that that there'd be some little genius out there that wanted to make several $billion that would find this new product?
Well, I know both private and public sectors of engineers, meaning both the DOTs and the consulting companies, are looking for that other silver bullet that would be a better alternative, that would help us be more sustainable and make our pavements last longer. But and we've experimented with using ground up tire rubber. We've experimented with using, instead of taking all the concrete or asphalt that was already there and shipping it off to the landfill, how about we crush that down and reuse it for road bed?
Well, they did that on the Highway 40 rebuild in St.
Correct.
Louis County.
Correct. And lastly, they've been doing some research additionally on using fly ash in concrete mixtures. Fly ash is the byproduct of an incinerator burning our trash and refuse, and that ash that's remaining, if you mix it into the concrete in replace of perhaps some of the cement, then we could be using a waste product and make it useful, and they've had some really promising results from that. So perhaps some of those new materials will come in, make our pavements last longer, but also use some of our recycled or reused materials. So.
Time for a contest. Like American Idol, only for engineers.
Yes, and I'm sure the Asphalt Institute and the Concrete Institute would be happy to sponsor such contests, but there's still active research going on, and we haven't found the best solution yet, but there's a lot of good ones out there, and we keep trying to improve. That's what we do as engineers, try to make life better.
Well, when you consider, that there's, I don't know, what do we have, like $100 billion worth of roads investment so far, somewhere in that neighborhood, and and much of it was built in the 1960s and 70s. So we're going to need to find something to maybe make the road system go further. Build to a 50 or a 70-year design standard instead of a 25, 30-year design standard.
And that goes back to our good friend cost, because it would just elevate the cost. Now, engineers don't just look at the one time,
but
we look at the life cycle.
But it's just incrementally more.
That's correct.
Because it takes a huge amount of money to reposition all the workers, 20 or 30 years later, as opposed to repositioning them 50 years later or 60 years later. So, I mean, if you can do it once instead of twice in, say, a 60-year period, then their cost savings in the long run is less, although politicians don't often think about the long run. They're always concerned about today's budget.
Yeah, some folks may say, I'll be retired by then, so.
Not my problem.
Yes, yeah. But it is. It's your kid's problem and your grandkids' problem then, unfortunately.
Exactly.
So,
and that's a very good point. We, as a society, we need to be thinking in those terms, not not just in, well, not my problem, or I don't want to deal with it. Now,
back to your point about heavy vehicles putting more of a load on than a passenger car. There's a huge difference between those two. So, just so that the public knows, a normal passenger vehicle, maybe 4,000 pounds, something like that. Compared to just a dump truck, for example. The difference between those two is about 10,000 in magnitude, meaning one dump truck going over your street is the same as 10,000 passenger cars going over the street. So those heavy vehicles, because of how much weight they have and the position of their axles, etc., all of that impacts the pavement. So now those heavy vehicles, they pay more in fuel taxes, especially those that are oversized or overweight, but they impact our roads a bit more than passenger cars.
Well, they may pay more in taxes, but not enough to actually fix the damage. Now, here's an interesting engineering question. Occasionally I'll see this truck that has an extra set of wheels that are lifted up, and sometimes they put them down. What's that all about?
The extra sets of wheels will help distribute the load on that vehicle so that it goes over a larger portion of the road surface. So in, I guess, the broad perspective, more tires means that you'll have less of an impact on the road, on the pavement itself. So
because you have less pounds per square inch on each spot you're traveling over.
Yes, yes. So although you're loading and unloading the pavement between each set of axles, you are also having less weight per axle. So one of the main reasons why a passenger car has such small impact on pavement is because there's maybe, 2,000 pounds on an axle, compared to maybe 10, 15,000 pounds on an axle for a heavy vehicle. So that large change between the pounds per axle certainly makes a big difference on what the wear and tear is on the pavement.
And what's the effect of, say, like what they call the double bottoms or the triple bottoms out west?
Well, it depends on the specific case. So and engineers have a method for determining how many loadings each type of vehicle would account for in the pavement.
Well, I guess my question is, does it make any difference if you have a double bottom, triple bottom truck going by versus a series of trucks that are driving down the road, one behind the other? Is there any difference to that, or is just the fact that you've got them that closely spaced that it's doing more flexing than it would be if you had another truck like right on your tail?
As long as if you had the same number of axles that were the same weights, then it would be considered the same impact on the pavement.
All right.
So.
Now let's move over to an area that you're working on right now, which, well, explain those three things that I was talking about at the very beginning.
Traffic operations.
Right, and transportation security, and now I'm blanking on the third one.
Real-time traveler information.
There it is, right,
Yes.
which you've been working with IDOT on.
That's correct. So right now we're working on research for the Illinois Department of Transportation to investigate how they are going to meet a new federal law that was passed in 2010, and departments of transportation need to be in compliance by November 2014.
And what does this compliance look like?
Well, it has to do with four main components, and overall the law says that if you're collecting real-time traveler information about your limited access roadways, for example, freeways. If you're collecting information, make sure that it's disseminated out to the public. So many times you may use an app on your phone to give you a travel time or suggest a route to a certain destination. If that app is telling you that there's congestion up ahead, that information comes from somewhere. So that information many times may come from the Department of Transportation while they monitor the roadways so that they can detect and clear traffic incidents as quickly as possible.
Are there monitors in the road? Is that how this is working? Or
That's correct. So in most metro areas around the U.S., there are monitors maybe every mile, every 2 miles, every 3 miles, but there'll be maybe a radar device that measures the speed. There may be sensors that are underneath or cut into the pavement, but all of those are meant to monitor the flow of traffic and the quality of travel so that if something does break down in the center of the freeway, we can identify it quickly,
because they can
clear
see
it quickly.
that traffic is not moving as quickly as it had been.
Because, and there's been many studies on this, and we've found overwhelmingly that it's worth our money as the public to fund service patrols to detect these and respond to these types of incidents quickly, because it's not only costing everyone valuable time, and they may be late for business appointments, late to pick up kids, etc., but it is also causing safety problems for a backup that's going up the highway. The end of that queue, the end of that progression of stopped vehicles, folks that are traveling freeway speeds that may not be paying attention, all of a sudden approaching stopped traffic, it creates a very dangerous situation, and there's been many fatal crashes because of that. So that's a secondary reason for funding the operations. And that's the other part of operating roadway, not just the maintenance of potholes and sealing cracks, but making sure that it's operating during rush hours at its best.
Yeah, years ago on Missouri and Interstate 270 on approach to 170, that very thing happened where a trucker lost his sense, he wasn't watching, traffic stopped, and literally ran over several cars that on this approach to getting off on 170.
That's unfortunate, but it happens more often than we'd like.
Mm-hmm.
So
the government has mandated that IDOT, MoDOT must provide this information publicly? Is that what you're saying?
yes, to start providing travel times along freeways in metro areas, but also start providing real-time information on construction lane closures, meaning it's great if you can tell the public in advance that there is likely going to be a lane closure for construction. However, when that lane closure goes into effect, they'd like the DOTs to start informing the public within real time, meaning within about 10 minutes in metro areas or within 20 minutes in a rural area. Start telling the public that lane is now closed, and then when construction's over, let everyone know lane is back open again, so that we can make informed travel decisions and again, use the infrastructure we have as optimally as we can.
And this shows up on your iPhone, your Android, or whatever it is you've got in your pocket.
Correct. So that information could come from DOT sensors, Department of Transportation sensors on the side of the roadway, or it also could come from GPS that's on many of the trucks we see driving down the roadway. Could also come from the app on your phone. Many times you're asked, do you allow Google or some other company to track you while you drive or have your app open? That information goes back and is averaged out, so privacy is protected, but that information goes to tell others upstream what are the travel conditions like and help make them aware of if they need to take another route.
Now, I don't know if this exists yet or not, because I'm not, the most tech-involved person, but does it exist, or will it exist, where when you're approaching one of these stops or problem areas, that your GPS or your phone can reroute you some other way around this?
Yes, that does exist, and researchers have worked on that for probably a decade or so, as far as how do we do this in real time, not just identify if a diversion route is good, but how do we tell the public in real time that this is the travel time on your alternate route, it's quicker than the travel time on the route you're currently on, we suggest changing. So those devices are in place commercially.
Now, these are the things that you were talking about, like on trucks, or is this for automobiles, or is it on your cell phone, or where would you find?
That sort of advice is available a couple different places. If you have a GPS in your vehicle, perhaps your GPS company will be collecting information about the travel time on your expected route. That's how it would give you an estimated arrival time. And it may update as you go down the road if travel conditions change. And
My
if
GPS is not smart. It's really dumb.
The,
As a matter of fact, when they build a new road and I drive on the new road, it shows me I'm in the middle of a field or some such thing.
yes, updates, they certainly help, and that's where I feel that maybe some of the in-vehicle GPS might start getting phased out as folks have more and more apps available for their smartphones and use their smartphones for navigation more and more. So apps like Google Maps, for example, might give you travel prediction. And there's several other types of apps as well.
As an engineer, what's your opinion of these, the attempt to have the driverless car?
It is something that's been around since the late 1990s.
Well, I remember years ago they had a design for what they called the Barrett guidance system, which I guess it had sensors on either side of the road, and the car was told to, to stay here, stay here. Now we got about 5 minutes. I told you things are going to go by fast here, so we've got about 5 minutes. So I don't want to waste a lot of time on this because you have a couple other things you want to talk about. But thumbs up, thumbs down in terms of driverless cars. Would you trust this?
Certainly, thumbs up. The technology's been around for almost 20 years. It's been tried and tested many different ways, many different approaches, and I feel that if commercial industry, like for example, car companies, are confident enough to put it in their vehicles, then I would feel very comfortable trusting it because we've done it before.
All right, transportation security then. You wrote a text.
That's correct.
What goes into a text on transportation security?
Our text focus mostly on what civil engineers need to know about transportation security. So how do you estimate an evacuation duration? How do you predict those sort of things? And how do you...
What does an evacuation duration mean?
That means if there was a mass evacuation, say of the St. Louis area, of the downtown,
empty out St.
how
Louis,
long would it take drivers to exit that hot zone, so to speak? How would they get out of the dangerous area and into safety.
Like the old days when they used to talk, oh yeah, nuclear war, we're going to get everybody out of town before that happens.
That's correct, and Illinois Department of Transportation has worked with us on a study like that, so they can be prepared if such an event takes place. They would be aware of what resources they might need, where they might need them, etc. So they're working hard to make sure that they're prepared for such things.
And what was that third?
With respect to travel time, with respect to real-time traveler information, there's two other pieces of information that they're mandated to provide. That is real-time weather information with respect to if a road's closed for snow, and then also real-time, we talked about construction, traffic incidents. As soon as they're aware of a traffic incident, it should be distributed to the public. And sometimes that's a challenge because IDOT isn't always made aware that there is a traffic incident on a roadway, especially in a very rural area in the middle of the night.
So what, the sensors would be out there, or how are...
There are road sensors, but in rural areas, they're spaced much further apart than they are in metro areas. So maybe sensors may detect speeds every 10 miles or more. So it'd take a very long time for those sensors to detect a crash or any sort of incident. And they would rely on folks and state police calling in to report.
Okay, so once a human being reports in, then that goes into this system that you're talking about,
Yes.
which then reports out to this GPS or to this magical system that suddenly you can look at your phone and get real-time information.
That's correct.
Although it's not so real-time, because...
Not always, but as real-time as reasonable. So as the DOT knows about it, they're expected to send it out to the public.
The last couple of minutes, and we're about there. Why would you suggest that somebody come to SIU, to the engineering school there?
Well, that's a loaded question, but we've got a great set of faculty there that have a lot of hands-on experience from industry to make sure that you're learning in the classroom what you will be doing in industry so that you can make an informed decision of what type of engineer you might want to be. We have started a new intro freshman program to make sure that engineers can start to improve their communication, so by the time they graduate they can be much better at their technical communication when they compared to when they started.
Yeah, I'll bet that could be.
So it's not just being able to do the design.
It used to be
communicating.
The scientists, they were good at doing the science, but being able to talk. Now writing is okay.
Yes.
But the talking part could be difficult for
It's got to be both.
For some people.
I tell them you can be the smartest engineer in the world with the best design, but if you can't convey that information, it's going to be difficult for you, or you'd be more successful if you could.
So in 15 seconds, what made you decide you wanted to be an engineer?
I wanted to build bridges. So I always played with Legos as a child and wanted to go do the real thing. And after some practice, I decided I'd love to go teach, inspire others to do the same. So
great. Thanks so much for being with us today. Appreciate it.
Thank you for having me.
And I've been speaking with Ryan Fries. He's an associate professor of engineering at Southern Illinois University, Edwardsville. Engineering's a very interesting area. You parents, you young people, you really ought to be thinking about that. This program is going to be uploaded to YouTube, so if you saw just part of it and want your kids to see it, take them to YouTube. Thank you very much. Goodbye.